In this presentation, I will present a few options for instructional computing models for the 2014-2018 Bond and Levy cycle. You'll remember from our earlier presentations that one of the goals of the 2014 Levy cycle will be to grow 21st century skills for students. In particular, this presentation is going to focus on the learning environment system of support, which allows students to achieve those desired outcomes. The Partnership for 21st Century Learning tells us that learning environments that support student outcomes in 21st century skills are those that enable students to learn in relevant, real-world 21st century contexts and that allow equitable access to quality learning tools, technologies, and resources. So these will be two things that we'll focus on in terms of the computing resources that students need to achieve those 21st century outcomes. Recall that in our Levy survey, we asked staff to tell us about their opinions regarding the expansion or maintenance of certain projects from the 2010 Levy cycle. In the case of computing resources, the total percentage of staff who indicated that we should either expand or maintain computing resources at their current levels for students far outweighed that response for other projects. For the purposes of this presentation, I'll talk about three different options for instructional computing for 2014. First, we'll look at a possibility for implementing a lower student-to-computer ratio using existing levy capacity built into the 2014 proposals. Next, I'll talk about what it would cost to possibly do a one-to-one implementation. Finally, I'll discuss costs around a bring-your-own technology or bring-your-own device initiative. Note that these options are not mutually exclusive. What that means is that some associated costs with, for example, the BYOT initiative would also apply in the case of a one-to-one or an increased student-to-computer ratio because of the need to support many more devices on the network. So let's look at option A, which would be to increase the computing capacity by using the existing proposed budget to implement a lower cost device at a better ratio than 5-to-1. Unpacking those survey results again, you can see that the support, represented here by the green and blue sections, for expanding access for students to district-owned and maintained computing technology was a strong favorite for additional projects or increased capacity within the 2014 levy cycle. Breaking that down by elementary and secondary, here's a slide that shows the results just for secondary responses. You'll note that the strong support decreased a little bit here, but the total support and somewhat support are still evident in terms of the increase in computing support for students in the 2014 levy cycle. Here's that same breakdown, but for elementary. You'll note here that the strong support section, or the green section, is much higher here than it was for secondary. And one possible explanation for that is that at most of our elementaries, the computing resources allocated to that school are tied up in things like the library and in desktop computer labs, and the frequency with which teachers have access to a mobile lab or a collection of laptops is a little lower than it is at the secondary level, where the number of resources allows them to have many more mobile labs, giving them a little more flexibility. So that could explain the difference. I'm sure there's other explanations as well. Staff are allowed to give us some open-ended comments in regards to the projects that we asked them about within the levy survey, and I've pulled out just a few here that I think are representative of what most people were saying. The Common Core standards are going to require a much higher level of tech savvy, especially among our younger kids, than we've expected before, and having more access to technology and more frequent access to technology is going to be an important key in getting them to those standards. Teachers did recognize that it's difficult to embed technology in teaching and learning when only half the class has access to laptops, or if they only have access during a given part of the week. Folks also addressed the idea that we would need to have more support in terms of help desk staff and technical support, and the current model that we have is just not sufficient to provide that for an increased number of computing devices. There were staff that believe that we have enough computers already and that we maybe need to focus our energies on learning how to use them better or more wisely. And staff also recognize the idea that we need to define what our curricular vision is before we can identify what that device is or what the best saturation of that device is. So in option A, as we start to think about cost of implementing a lower student-to-computer ratio, in this option, we'll look at using the existing STP capacity, and you'll remember that was about 8.6 million, to implement less expensive devices at a higher ratio. So some benefits there would be a higher rate of access for students. More devices means more frequency of use. An ease of use for tablet and touch devices, so probably fewer pain points in terms of getting students up and going with the use of these tools. A higher use rate for younger students and special ed students who might not have the motor skills it takes to function with a mouse or function with a keyboard. And then certainly some relevance. Tablet and touch devices are becoming very prolific in daily use in many families, so the idea of relevance is there. Some challenges that we would face here would be having a wider variety of devices to support. We'd have to address our increased need for building out our infrastructure. And the management of apps and software on tablet devices is a little bit uncharted territory, so that would take some thinking. And then accessories, we have to think about cases, styluses, keyboards for tablet devices to allow kids access to easier word processing and perhaps the requirements of online testing. Recall from our earlier presentation about instructional computing that the existing STP states that this project would provide resources to modernize all student and staff workstations to maintain the 2013 levels of access. However, in this proposal, option A, we would be looking at alternative computing devices that are of lower cost than what the existing STP is built on in terms of laptops. So that could allow us to implement tablets or e-readers, some sort of laptop light like a Chromebook or netbook, perhaps support for student-owned devices on NSD networks, although I'll talk a little bit about that more in the BYOT section, and then services to support a diverse ecosystem. So these are all things that we could explore using the existing capacity, and in this option I'll explore that a little more in detail. So you'll remember that this is the budget capacity breakdown for the instructional computing project, and the lines that we'd be messing with here in order to implement a better ratio would be the student devices line and to some extent the staff devices line to be able to implement a lower cost computing technology. So that represents the majority of this budget. However, certain accommodations such as carts will need to be made to ensure that the new devices, the less expensive devices, are still taken care of. The special ed, sub, circ stations, etc. are probably still going to be necessary, so they would still be included in the cost. So here's one example of what it might look like to try to achieve a 3-to-1 ratio. And in this example, just for ease of example, I'm going to use a $600 iPad as that device. So just running down the lines here, you'll see that student laptops and desktops would still be needed to do certain functions of the district, but we certainly wouldn't need them at the ratio that that are currently implemented. Staff devices would be needed to support staff in being able to do the basic functions of their job. Right now, for example, our student information system is not tablet friendly, so just as an example, staff would still need a laptop to build presentations and develop lesson plans and things like that. Staff devices to support a 3-to-1 in this example suggests that staff would need access to a device that's similar to what students will be using so that staff can more successfully integrate that device into their teaching and learning activities. We would still need shared circulation, presentation, and sub laptops just like we have now, although it is possible that we could reduce the number of those machines needed. The student devices, in terms of implementing that less expensive but more ubiquitous device, we would need about 5,600 of these devices over the course of the levy cycle to get to 3-to-1. And we would still need special ed devices to make sure that kids in those populations had access to the curriculum in the same way that general ed students had. We would probably need some planning resources. These are devices we haven't deployed before on a large scale, and we'd have to think about management of apps and software as well as the devices themselves, so we would need some support in being able to do that. We would need some testing equipment, servers and devices themselves and software. We would need some carts, and then we would need to build in some support for an increased number of devices across the district. So this keeps us pretty close to the existing STP capacity, and this iPad example is really just that. It's just an example of how we might better that ratio given a lower cost device. Next, I'll present some information regarding what it would cost to implement a one-to-one initiative, where a one-to-one would be every student at a specified grade level or grade levels would receive a device assigned to them for their use throughout the school year in all activities. So in this proposal, which I'll call option B, or one-to-one, we would be increasing the existing STP budget capacity to provide for a one-to-one initiative. So the 8.6 or so million from that earlier proposal would need to increase to support one-to-one because we'd have many more devices. Among the benefits of a one-to-one would be the ubiquitous standardized access to supported devices. This makes it possible for teachers to count on students having access to the same device within all teaching and learning activities. We'd eliminate the digital divide, meaning that students who didn't have access to these devices at home now would, assuming we let them take them home. There would be increased opportunity for more teacher and technology integration because they could count on essentially 24/7 access to the same kind of device that they themselves have access to. One-to-one research shows that this kind of initiative allows for personalized learning for students. They take ownership and accountability for their learning on the device that's been assigned to them that they can personalize to themselves. Lots of opportunity to move from teacher-centered to learner-centered activities. If we allow students to take them home, the learning goes home with them. And we wouldn't be the first to do this, so there'd be a benefit in terms of implementation. Certainly there would be some challenges in terms of implementing a one-to-one. The first being, this would be a major change for staff and families and instruction. Pedagogies would have to change. Staff interpretations of how technology is used could change. Families would certainly need some support in understanding how to care for that device and use it at home. As I said in the first proposal, there would be an increase in infrastructure needs. Having many more devices on the network is going to have a ripple effect on the number of wireless access points needed, for example. We would also have an increase in support costs. We would need additional systems and staff to be able to support the vast increase in the number of devices on the network and in the hands of kids and teachers. There would be a professional development need for teachers to help them understand how to use that device in a more pervasive manner in their classroom. We would have to think about things like loss and damage and come up with some policies that address those issues. We need to consider the idea of insurance and certainly need to consider app management, especially on tablet devices. Online testing requirements. Some online testing systems do allow for the idea of a tablet, but only of certain sizes. So if we're comparing, for example, an iPad, a standard iPad versus an iPad mini, we might run into some issues there. We'll also have to think about things like accessories, and we talked about this a little bit in the first option. We might need keyboards. We'll probably definitely need cases, and in some cases we might also need styluses on certain kinds of devices to support students with motor issues or special ed concerns. We'll need to definitely consider parent education and support from home, what happens in cases of technical need, or in the case that they don't have home internet access. These are things that we'll need to consider if we really want that learning to go home and be personal for the student and the family. There's a ton of research out there regarding one-to-one, especially as districts come on board with this, and this type of initiative has been around for a while. But I'll focus on two research reports in particular. One is the report put out by Project RED, which is Revolutionizing Education Through Technology. And I'll also talk a bit about the results from the Horizon report for 2012-2013. Both of these reports can be found in the TAC shared items in Google Docs. So if you want to read more thoroughly or more extensively, you're welcome to take a look at those reports. The Project RED report revealed 7 major findings of interest to schools embarking on some sort of one-to-one or even just a technology implementation in general. And I'll list those here. So the first one is that proper implementation of technology is linked to education success. And this seems like a pretty generic statement, but this definition of proper implementation turns out to be pretty important, and we'll get into what that looks like in just a minute. The second finding was that properly implemented technology saves money. Well, of course it does if you implement it properly. Finding number 3 suggested that one-to-one schools that properly implemented technology outperform all other schools, including all other one-to-one schools. So the findings here suggest that how the technology is implemented and used has a major impact on student outcomes. And if not properly implemented, one-to-one schools have little to no impact compared to those that properly implement that technology. Continuing those findings, number 4 was that a school principal's ability to lead is critical to the success of an implementation effort. We cannot undervalue the importance of having a strong instructional leader as part of the success of that implementation. Number 5, technology transformed intervention improves learning. This is the idea of putting devices into learning environments where students need intervention. They need just-in-time teaching. They need access to remediation or extension. And the research here shows that it improves learning when technology is in those spaces. Number 6, online collaboration increases learning productivity and student engagement. So this one example might be the use of Edmodo. Number 7, the daily use of technology delivers the best return on investment. In a 5-to-1 student-to-computer ratio, it's very difficult to get daily use of technology without limiting the segments of time that kids actually have access to that technology. So this suggests that having a better student-to-computer ratio would have some more impact on student learning outcomes than would, say, our current 5-to-1. So remember that the first few findings in the Project Red report referred to this idea of proper implementation. And these implementation factors are listed here. We'll talk about them a little bit. So number 1 is this idea of intervention classes. Technology is integrated into every intervention class period. Intervention classes include ELL, Title I, Special Ed, and Reading Intervention programs. Number 2, change management leadership by principal. Leaders provide time for teacher professional learning and professional collaboration at least monthly. This is really important as the technology becomes more pervasive and more a part of the fabric of what we do in teaching and learning and also in our business activities. The principal really needs to take a leadership role in shepherding those changes forward. Number 3, online collaboration. Students use technology daily for online collaboration in terms of games, simulation, and social media. Again, using that example of Edmodo, that's just one structure that teachers and learners can use to engage in online collaboration both during the school day and asynchronously outside the school day. Core subjects. Students need to see that technology is integrated into core curriculum weekly or more frequently. By core curriculum, we're talking about math, science, language arts, world language, social studies. These are really key components and needs to be part of core curriculum and not an add-on as part of an elective or as a separate course in and of itself. Number 5, online formative assessments. Assessments are done at least weekly. Unless teachers are creating these assessments themselves, this needs to be considered as a cost of implementation in terms of teachers having the ability to collect formative assessment information in a system that reports back to them quickly and where they have a minimal amount of editing or setup needed. Number 6, student-computer ratio. This is what we've been talking about in the last proposal and in this one as well. Lower ratios improve outcomes. So even if we can't afford to do a one-to-one, we certainly should strive toward lowering that student-to-computer ratio, according to this research. Number 7, virtual field trips. Virtual field trips are done at least monthly. This is the idea that we would use tools such as Google Video Chat or Skype to visit with experts, to go to places we couldn't otherwise go, to explore environments, laboratories, museums, things like that from within the classroom. These are done at least monthly. This was one of the Project Red implementation factors as well. Number 8, search engines students use daily. This is a very relevant activity that all of us as adults do in our daily life. We need to encourage students to do that as well and to be smart about the information that they find or that is returned to them through these searches. And then number 9, principal training. Principals are trained to lead effective implementation. Principals must ensure teacher buy-in and model best practices. Again, this gets at that idea of that change management and the critical role that the principal plays in fidelity in terms of the implementation of technology. The 2012-2013 Horizon Report has a section on one-to-one and mobile devices, and specifically a paragraph in that report suggests that more schools are choosing tablets as one-to-one devices because of how easy it is to share screens, how easy it is to move them in and out of the learning environment, and to enhance this idea of inquiry-based or challenge-based learning. So tablet would definitely be something for us to consider in terms of implementing a one-to-one. In order to look at a model for what it would cost to implement one-to-one, we're going to make some assumptions here. The first is that one-to-one is generally believed to be effective in grades 5 through 12, although we know that primary kids are becoming more tech savvy and in fact need to become even more so given the requirements of things like the Smarter Balanced Assessment. Students not affected by one-to-one would still need some sort of computing access appropriate to the instructional vision of the district. Schools would still need a set of resources to support basic functions such as online testing, particularly if the devices that we implement do not meet the basic requirements of either our state's MSP test or the federal Smarter Balanced Assessment. Implementation would need to be rolling, where we do a few grades per year. We simply don't have the staff or the knowledge or expertise to be able to roll all the grade levels out at once. This would also allow us to be smart and thoughtful about subsequent years as we learn more about what's best practice in terms of handing devices out to students. Support and network infrastructure and staffing would have to increase parallel to those one-to-one efforts. And again, with a rolling deployment, we can sort of stagger that work out so that it doesn't stress the system to the point where the implementation isn't effective. Staff would also need devices to support their work. They'd likely need a laptop and whatever that one-to-one device is to match what the students have so that they could both plan their lessons and be comfortable with the technology in a way that supports that integration into their teaching and learning. And this also assumes that students would take devices home, although there are one-to-one implementations that we're aware of where students leave those devices on campus. So here are some basic costs associated with doing a one-to-one from grades 5 to 12. And again, these are based on assumptions where we are rolling this out year after year to a couple of grade levels, not to the whole group. And in this particular example, we're again looking at a $600 tablet device of some sort. So you'll see that in year 1, we implement at grades 5 and 6. Year 2, we add grades 7 and 8. So we'd be buying devices essentially for grades 5 and 8. In year 3, we'd support devices in grades 5 to 10, and then in year 4, grades 5 through 12. So you're essentially adding 2 grade levels worth of devices each year, along with the number of teacher devices that would be needed to support that implementation. So you can see a row there that talks about the total cost for the added devices. Underneath that is a row that talks about deployment services per device. We generally contract deployment services out with a provider who can help us do the the heavy lifting, the unpackaging, the initial configuration, and things like that. We would definitely need some project management and consulting resources to help us plan this effectively, and we would probably hire a contractor of some sort from the outside to help support making sure that we did this thoughtfully and that we had thought about the right variables in terms of insurance and home access and things like that. Technical support would need to be added in as well. As we increase the number of devices, we would need to have some initial technical support to make sure that those devices were properly configured, that we were able to manage them remotely, that the distribution of apps or learning materials was efficient and possible. And that will increase over time. The need for that support for those years will increase over time as we have more devices in the system. Training for staff would need to be included as well, and in this particular model we look at training staff the year prior to the grade levels in which they're affected. We would also need to look at peripheral devices such as adapters, styluses, keyboards, and cases. Those would need to be part of the implementation of those devices as well. Many school districts build in a cost for a certain number of basic apps that would be part of the device to help kids do just basic productivity tasks, word processing, research, PDF annotation, and certain types of readers. And then testing equipment. In order to have a successful implementation of centrally managed devices, we need to have equipment on board that will help us to distribute apps and to test different management systems. So you can see the total cost here is right around 11.7 million. And again, this is based on the assumptions in that earlier slide that we would implement in grades 5 to 12. Certainly the cost would decrease if we shrunk that grade band down to, let's say, all secondary schools. And we can certainly look at those models later if you'd like. It's important to note that that 11.7 million in the previous slide does not include a few costs. One would be the cost for equipment needed to perform basic functions, such as perhaps online testing. If we spent a bunch of money on tablets or e-readers that didn't support the state's online testing software, Smarter Balance, then we would still need to purchase additional equipment to allow for online testing. We would also need to allow for costs related to equipment needed to run some specific software applications. Not everything is tablet friendly. Particularly in special ed and assistive tech, there are some applications that need a computer to run. And we have some adopted approved curriculum that is not tablet friendly. Staff would also need some sort of laptop or desktop to support their basic functions. Again, I used the student information system example a couple of times, but that's something that is not currently tablet friendly. We would also need administrative computers to run more extensive software for data analysis and different kinds of communications. And of course, this proposal doesn't include the costs related to the infrastructure that would be needed to support this many devices. Just like the last proposal, if we're going to increase the number of devices, we need to increase the infrastructure to support those devices. In the last section of this presentation, I'll talk about costs related to implementing a Bring Your Own Technology or Bring Your Own Device initiative, where we would open up the network to allow students to bring in any internet-capable, any web-enabled device that they had access to and wanted to bring to school. That could be a laptop, it could be a tablet, it could be a phone, it could be all three for one student. We asked our staff to respond to the idea of a Bring Your Own Technology initiative in our Levy survey, and the results here show this is everybody, all elementary and secondary, and the support for BYOT, where the green section is strongly support and the blue section is somewhat support. Orange is not support and gray is not sure. We broke those results out by secondary and elementary, and this slide shows the responses just from secondary staff in terms of BYOT. The combined areas of strong support or moderate support for BYOT are roughly equivalent to what they are for the entire set of respondents, but the green section for strong support is just ever so slightly higher. Here are the results for elementary only, and you'll see that the strong support section is significantly less than that of the combined group and less than that for the secondary folks. And there are certainly some explanations that are possible, one being that at elementary, the idea that students, particularly in the primary grades, could bring a device to school might be a little terrifying for some elementary teachers who are helping those students to manage simple tasks like tying shoes and walking in a line, and the idea of having a student also be responsible for, in some cases, an expensive piece of technology might be a little off-putting to some of our elementary folks. The open-ended comments on the survey regarding Bring Your Own Technology fell into one of several themes, the first being the idea of professional development, and this is represented in the first comment here. where teachers recognize the idea that in a BYOT environment, you might have a classroom with between 3 and 6 different types of devices and platforms. And to be able to manage a lesson and manage teaching and learning within that context could be difficult unless you have some good classroom management strategies and a good awareness of how these systems talk to each other or can talk to each other using things, services like Edmodo. There's also a concern about equity, where students bringing in different types of devices set themselves up for conversations around, my device is better than yours, or my device does more things than yours, etc. So there's definitely a concern about equity. Teachers do seem to realize that this could be a cost-effective way to bring more technology into our schools. Again, with the recognition that it's going to require some professional development and that there could be some cost savings in terms of support, not having to support student devices that they own and bring with them to school. There also seems to be a recognition among staff members that particular students with special needs could really benefit from a BYOT. Instead of the district spending dollars to maintain a device that that we give to a student that they may already have access to at home, might be better suited for that student's needs to have them use their own device, and for us to support them in using different adaptive software and things on that device so that they can take that device with them and have it with them as a part of their lifestyle. We also have teachers who express the overall concern that network security and filtering would be an issue as well, and that needs to be addressed in order for a successful BYOT initiative to take shape. So in this proposal, we would be adding sufficient capacity for changes to infrastructure support and training to implement a BYOT initiative. The benefits here would be, among many, the personal ownership of learning and outcomes. If a student is bringing their own device to and from school with them, where it can be personalized with software and settings that meet their needs, it's likely that they'll take more personal ownership of their learning as well. Life skills related to care of technology and ownership. These are skills that students would obtain given the need to protect and care for their own device, and as opposed to a district-owned device, which they're going to have to turn in at the end of some time period. This would mean a reduced computing cost for our district, but not a zero cost. We would still need access to computing devices for a number of different types of tasks. One option related to computer distribution might be to keep our current 5-to-1 funding model, but redistribute those existing resources in some way. We could even do BYOT and some form of the bettered ratio presented in option A, where we change the ratio at certain levels in the district and also include a BYOT at certain other grade levels in the district. We may have fewer district-related support responsibilities with a BYOT. Many districts around us have recommended to us that if we're going to do a BYOT, that we don't put our hands on student-owned devices just for sake of liability and tech support issues that come up. Teachers would have the opportunity to increase the amount of integration they do in classrooms if the assumption is that all students will have ubiquitous access to some sort of web-enabled device. And just like with some of the prior proposals here, we have an opportunity to move from teacher-centered to learner-centered teaching and learning. If students are taking ownership of their device and the learning within, then we can move away from Sage on the Stage type teaching and perhaps more into a challenge-based or problem-based learning environment. Students bringing their devices to and from school implies that the learning also goes home with them, that it doesn't turn off as soon as they walk out our school doors. And others have done this before, so we can learn from the implementation successes and challenges that other districts have faced as they have implemented a BYOT. A Bring Your Own Device initiative is not without its challenges, of course. One big one being the creation of a diverse ecosystem of devices. As I mentioned before, teachers could very well be daunted by the diversity of device within their own classroom. Planning a lesson that acknowledges the functionality of up to 5 or 8 different platforms and devices could be a real challenge for teachers, and that would be something we would need to manage. Equity, the district should probably provide devices for students who don't have them at home. It's one thing to say bring your own device, but if students don't have them to bring, then we have a responsibility to provide some of those. So there could be some additional costs associated with that, or we could repurpose some of the costs within the 5-to-1 STP proposal, such that anywhere there was BYOT supported, additional devices could be provided for kids who don't have them. Common systems for collaboration, we would need to put some systems in place that would allow platform agnostic collaboration and document sharing, so that students with laptops versus students with tablets versus students with smartphones all had the ability to exchange information and data and share ideas and planning opportunities with each other. There would definitely be infrastructure costs with this proposal, as with the others as well. And that exhibits the primary cost for this particular proposal, which would be the infrastructure needed to support a wide variety of devices on the network. Family communication and preparation would be necessary here. Some families may not be comfortable with their students bringing devices to school. Other families are going to wonder, what happens if my student's device breaks at school? What should I do? Who should I call? Those are all things we would need to acknowledge. 3G and 4G connections will be around whether or not we do a BYOT device or not, and we have no way to manage the 3G and 4G connections that students might make on their devices, which means they have access to content that we can't filter, and that would need to be something addressed in terms of the acceptable use policy or any sort of BYOT policies that we put in place as part of this project. Many teachers continue to have a perception that BYOT initiative would increase discipline issues where students are using their devices for ill, and that would need to be addressed and properly managed as well. And we would definitely need to revise our acceptable use policy if we were to implement any sort of BYOT to make sure that it was clear what the expectations were in terms of how those devices are used in teaching and learning on our campuses. Project Tomorrow, which is a national nonprofit organization founded on the idea that students should be empowered to use technology in teaching and learning, does a research study each year called Speak Up. And this slide presents a couple of the findings from the 2011 survey. Access to devices is increasing dramatically. Middle school kids with tablets doubled from 2010 to 2011 from 13% to 26%. And again, it's 2013, so that number is probably higher now than it was then. Students cite an inability to use devices at school as an obstacle, but as of 2011, 2/3 of principals still didn't plan to allow the devices in school. The research study also found that students want to leverage their device's functionality to collaborate, organize, and personalize learning. So there is a motivation on the part of the students to use their own devices to accomplish tasks at school that are relevant and meaningful. And nearly 2/3 of parents, according to this survey, would buy a mobile device and 52% a data plan if used for academic purposes. And we could do some similar information gathering within our own district. I suspect that we might find some similar results. In 2009, the Joan Gantz Cooney Center and the Sesame Workshop put out a document called Pockets of Potential, which explored the challenges and benefits of mobile learning initiatives. The key opportunities that they outlined were numerous. There are a few listed here. One is the idea that mobile initiatives encourage anywhere, anytime learning. So this idea that the technology is present in the learning moment, both in the standard classroom environment and also out in the field, so to speak, is a pretty powerful opportunity. This document also suggested that mobile device initiative, mobile learning initiative, improves 21st century social interactions. So empowering students to use those devices to interact with each other in a safe and monitored environment helps to develop 21st century skills in the area of communication and digital citizenship. Mobile devices are a great fit for learning environments, especially where space is at a premium and you may not have the infrastructure or even the time to be, rolling in a cart or plugging things in or sitting students at desktops where you want those devices to be in their laps, in their hands, in front of their face, and being used in collaborative activities. And the fifth and final key opportunity outlined in the document was that mobile devices enable a personalized learning experience. We've talked about this in the previous proposals as well, but the ability to use a mobile device to personalize the learning environment, the technical learning environment for students, is pretty powerful and gets those students to take ownership of their learning in a way that using a standardized vanilla district-owned computer really does not. Pockets of Potential also outlined a few key challenges with mobile initiatives, one being the negative aspects of mobile learning. The idea that a mobile device that's owned by the student comes to school with content on it that may be a distraction or an opportunity for students to engage in unethical behavior presents a real problem when it comes to using that device in the classroom. There are also some physical health concerns, eyesight and motor skills being developed, thumb problems, carpal tunnel syndrome. These are all things that have been reported with mobile devices. And certainly there are some concerns with data privacy, students leaving devices behind or giving access to other students to that data. Those are problematic as well. At the time that this report was published, the cultural norms and attitudes were also a key challenge in terms of parents and teachers not necessarily being convinced that mobile devices were a potential advantage to the learning environment. Now, certainly a few years have passed and that could have changed, but there still exists some cultural expectations and assumptions as far as how devices are used, either to the good or to the detriment of learning in the classroom. So this would definitely need to be addressed if we were to do any sort of mobile device initiative, any sort of BYOT. Pockets of Potential also identified clearly that there was no mobile theory of learning. And what that means is that there aren't strategies embedded within curriculum or with instructional frameworks that address this idea of having access to mobile technologies within the classroom. So this has impacts on pedagogy and design of new ways of teaching and learning, and there really is no widely accepted theory along these lines. So it's difficult to know what the best practices are in terms of implementation. Now again, this report came out in 2009, so significant changes have come about in terms of what people are finding in the research around how to use mobile devices in the classroom. And curriculum publishers are certainly coming along in terms of implementing apps and content that's more mobile device friendly. But again, there's not necessarily a guide to best practices for mobile device implementation. And then finally, this idea of differentiated access and technology. So we've talked about a little bit about this before, that the diversity of devices within a single classroom represents a challenge for teachers in terms of managing content that they distribute to students on those devices and how students interact with each other and with the teacher on those devices, given inconsistencies between type of hardware and operating system. Thinking about the costs associated with BYOT, most of the significant costs that we haven't looked at yet are going to be in infrastructure. The ability to provide protective network access to students bringing devices onto campus. Most of that additional cost is going to be in wireless access points, in building out the network and implementing some increased security protocols and things like that. We should also, though, consider that there are going to be costs associated with purchasing devices for kids who have none, and certainly that capacity could come through the initial STP, which we valued at about 8.6 million. And we could implement some hybrid of BYOT and the option A, which is to lower the student-computer ratio, so that we could, effectively do both, where certain grade levels would be impacted by BYOT and certain grade levels would be impacted by a reduced student-to-computer ratio. Training costs for staff to implement diverse device sets. This is going to be a cost that we would need to consider given assumptions we make about what kinds of devices are going to come in and how staff can effectively leverage those devices in the learning moment. We'll also need to be thinking about systems to support collaboration across multiple platforms. Again, just for sake of example, I'll use Edmodo, which has apps both in the iPad, iTunes market, the Android market, and is web friendly as well. So a system like that would need to be in place to support collaboration between teachers and students. There would certainly be costs associated with devices to administer online testing and other required productivity tasks. A BYOT doesn't eliminate the need to purchase computers for the district. We'd also need to include support costs for ensuring that student devices have the right apps and tools that they need to get the job done, so to speak. So in summary, we've looked at 3 different options for instructional computing within the 2014 Bond and Levy cycle. A summary of those options is listed for you here, where option A was to implement a lower student-to-computer ratio, where we take the existing budget capacity, which was about 8.7 million, to implement a lower cost device at a better ratio. And that could also mean that we implement certain types of devices at certain grade levels and other types of devices at other grade levels. We need to think about that in the context of what our instructional vision dictates. We looked at option B, which was to implement a one-to-one. That would mean increasing the STP's capacity to fund one-to-one, and that could be anywhere from 12 million to 15 million, because we would need to include not only the cost of the device, but also things like peripherals and app support and systems for managing the devices, as well as computing resources to support the administrative functions of the district and the basic requirements that teachers have to develop content and lesson plans and things like that. Option C was to implement a BYOT or BYOD sort of initiative, and that the major cost there would be in the infrastructure capacity. We would need to build out the infrastructure to support an increased number of devices, and in fact the cost here is also replicated in the one-to-one and in the lower student-to-computer ratio options A and B, because we're talking about increasing the number of devices. In a BYOT situation, we would also need to consider using all or most of the capacity in the existing STP to make sure that we had computing devices sufficient to meet the needs of students not impacted by BYOT and to support staff in the basic functions of their job. That all basically suggests that all of these options are not mutually exclusive. The TAC will have the arduous task of figuring out what the threshold is and what our goals are and how we can implement those goals to increase access to computing resources for students to meet the instructional vision of the district.